Hello friends, welcome to Edita's program. Today is the last day for me to give a lecture. So and this is the last bit of our according to our syllabus. That is the last very small bit. So yesterday I started second order homogeneous linear equations. How to solve the second order homogeneous linear equation. I think so I have explained already. Second order homogeneous equation. D squared y by dx squared with coefficient a plus b into dy by dx plus c of y is equal to f of x. But actually in previous class I have written f of x y, but it is not f of x y, it is f x. Already we have taken the y value this side. So this is a second order linear equation, but we are going to study second order homogeneous linear equation. If f of x is equal to 0, it is become a into d squared y by dx squared plus b into dy by dx plus cy is equal to 0. This is a homogeneous second order linear equation. Now we will see how to solve this equation. Put d squared y by dx squared is equal to and dy by dx is equal to dfy. Therefore, this equation becomes a into d squared y plus b into dfy plus cy is equal to 0. That is f of dfy is equal to 0. That is f of d is equal to 0. Put d is equal to m, then f of m is equal to 0. This is called auxiliary equation. It is called auxiliary equation. So f of m is equal to 0, that is a into d squared plus b into d plus c is equal to 0. In the place of d, if you put m squared plus bm plus c is equal to 0. This is an auxiliary equation this is called auxiliary equation of the given second order homogeneous differential equation, and we know it very well, that is a quadratic equation in M. This is a quadratic equation. In M. Varga Sameekarana, in Kannada we will read it as Varga Sameekarana. In the place of quadratic equation we call it as,
don't write below, to some extent to hide below base.
Okay, ವರ್ಗ ಸಮೀಕರಣಗಳನ್ನು ಸಾಧಿಸುವಿಕೆ. We know it very well. Every quadratic equation have two roots. Every quadratic equation have two wheels. That means here m has two values. We will see now. First you find the values of m using factorization or using the formula. You know it very well. When the equation is ax squared plus bx plus c is equal to 0, then x is equal to minus b plus or minus square root of b squared minus 4ac divided by 2a. How to solve the quadratic equation? First method is by factorization, the second method is using formula. Find the values of m first, then its solution is case 1, m as 2 roots, 2 real and distinct roots, real and distinct roots or values. M has 2 real and distinct values, say m1 and m2. Then the solution is y is equal to c1 e to the power of m1x plus c2 e to the power of m2x. This is the solution of the given homogeneous second order linear equation. When the quadratic equation has 2 real and distinct roots, then we are having a solution y is equal to c1 into e to the power of m1x plus c2 e to the power of m2x. Second case 2, 2 equal roots, m has equal roots, say then the solution is y is equal to c1 plus c2x into e to the power of mx. Look here, this equation when it has 2 equal roots, let us say m and n, then the solution is y is equal to c1 plus c2x e whole in the bracket e to the power of mx. Suppose it has 3 values, all the 3 are equal. We are going to write y is equal to c1 plus c2x plus c3x squared, that is in the bracket into e to the power of mx. But as according to your syllabus you are having only second order. So, say when the second order is highest derivative, you are having only 2 values. Third case, roots are imaginary. Roots are imaginary. Then the solution is y is equal to e to the power, say let us take that m is equal to alpha plus or minus I beta. When the roots are imaginary, that must be a complex number, m is equal to alpha plus or minus I beta. Then solution is equal to e to the power of alpha x into c1 cos beta x plus c2 sin beta x. Only this is the theory part about the homogeneous differential linear equation. You have to remember the 3 cases. In the first case, when the quadratic equation has 2 real and distinct roots, solution is y is equal to c1 e to the power of m1x plus c2 e to the power of m2x. The second case, roots are equal, say m and m, then the solution is c1 plus c2x whole to the power of c1 plus c2x in the bracket e to the power of mx. In the third case, roots are imaginary, that means roots are complex number, say alpha plus or minus I beta, then the solution is y is equal to e to the power of alpha x into c1 cos beta x plus c2 sin beta x. Quadratic equation, you know it very well how to solve the equation, by factorization or by using formula. Find the values of m. If you know just like a formula these 3 cases, directly you can substitute the values in the place of m. Okay, we will solve the problems. First one, solve d squared y by dx squared, d squared y by dx squared plus 3 into dy by dx plus 3 into dy by dx plus 2y is equal to 0. So, is equal to 0, therefore, it is a homogeneous equation, it is a linear equation. Coefficients are a is equal to 1, b is equal to 3, c is equal to 2. First you write, so d squared y by dx squared is d squared of y plus 3 into d of y plus 2y is equal to 0. That can be written as d squared plus 3d plus 2 of y is equal to 0. Put d is equal to m, then it is become a auxiliary equation, that is m squared plus 3m plus 2 y is equal to 0, that is m squared plus 3m plus 2 is equal to 0. See, it is a quadratic equation, easily we can find the values of m using factorization. 2 ones are 2, that is m plus 1, m plus 2, 2 plus 1 is 3, that is m is equal to minus 1 and m is equal to minus 2. So, the values are m is equal to minus 1 and m is equal to minus 2, that is according to the first case. Solution is the first one, the solution is y is equal to c1 e to the power of minus 6 plus c2 e to the power of 2x. This is the solution of the given homogeneous linear equation, second order homogeneous linear equation. Just how to put this equation in the form of auxiliary equation. This is an auxiliary equation. Find the values of m and write the solution as it is in the case 1. Now, we will go to the next problem. The second one, solve d squared minus 3d plus 4. So, it is a homogeneous equation and second order linear equation, and he has given directly in terms of d. Solution given d squared minus 3d plus 4, put d is equal to m, that is m squared minus 3m plus 4 m squared minus 3m plus 4 is equal to 0. This is auxiliary equation. This is called auxiliary equation, and we know it very well, it is a quadratic equation in m. So, 4 is there, 4 ones are 4, minus 4 plus 1, that is minus 4 plus 1, quadratic equation. That can be written as m minus 4 is equal to 0 or m plus 1 is equal to 0. M is equal to 4, m is equal to minus 1. Therefore, the solution is y is equal to c1 e to the power of 4x plus c2 e to the power of minus 6. This is the solution of the given second order homogeneous differential equation. Let us see the third one. Solve d squared y by dx squared minus 7 dy plus 12y is equal to 0, plus 12y is equal to 0. These problems are very simple. If you know the quadratic equation and how to solve the quadratic equation, that is enough to find the solution of the differential equation. Solution: given d squared y by dx squared minus 7 dy by dx plus 12y is equal to 0. That can be written as d squared of y minus 7 d of y plus 12y, that is d squared minus 7d plus 12 of y is equal to 0. Put d is equal to m, that is m squared 7m plus 12y is equal to 0. That implies m squared minus 7m plus 12 equal to 0. This is an auxiliary equation. This is called auxiliary equation. So, we know it very well, it is a factorization, it is a quadratic equation in m. We can easily solve this, find the values of m by factorization. 4 3s are 12, minus 4 minus 3, that is equal to minus 7, that is m minus 3, m minus 4, this is equal to 0, that is m minus 3 is equal to 0 or m minus 4 is equal to 0, that is m is equal to 3. Therefore, its solution is y is equal to c1 e to the power of 3x plus c2 e to the power of 4x. So, like this, if it is possible to find the values of m by factorization, it is very easy to find the solution of the given second order homogeneous differential equation. Now, we will go to the next second case. When the roots are equal, fourth one, solve d squared minus 4 is equal to 0. That is solution: given d squared minus 4 into y is equal to 0. Put d is equal to m, that is m squared minus 4 into y is equal to 0. M squared minus 4 is equal to 0, that is m squared is equal to 4. M is equal to plus or minus 4. Roots are distinct, real and distinct. The solution is y is equal to c1 plus or minus 2, root 4 is 2, c1 e to the power of 2x plus c2 e to the power of minus 2x. This is the solution of the given differential equation. Solve d squared y by dx squared minus 6 dy by dx plus 9y is equal to 0. 9y is equal to 0. Solution given d squared y minus 6 dfy plus 9 of y is equal to 0. 9 of y is equal to 0. 6 d of y, that is d squared minus 6d plus 9 is equal to 0. Put d is equal to m, that is m squared minus 6m plus 9 into y is equal to 0. That implies m squared minus 6m plus 9 is equal to 0. That is m minus 3 whole squared is equal to 0. M squared minus 2 into 3 into m plus 3 squared. See, I will write the another step, I will show it. That is m squared 2 into m into 3 plus 3 square. A squared minus 2ab plus b squared, that is a minus b whole squared equal to 0. The next, that is m is equal to 3 and 3, roots are equal. M minus 3 whole squared is equal to 0, m minus 3 is equal to 0, therefore m is equal to 3. But we know it very well, m has 2 values, therefore m minus 3 into m minus 3, m is equal to 3, again m is equal to 3 you will get. So m is equal to 3 and 3. Therefore the solution is second case, the roots are equal, the roots are real and equal. Y is equal to c1 c2x e to the power of 3x. When the roots are equal, then c1 plus c2x into e to the power of, what is the value of m? We have to write there, e to the power of 3x. When the roots are real and equal, so we will get the solution y is equal to c1 plus c2x in the bracket e to the power of mx. M value is here 3. So when the roots are equal, how to find the solution of the given differential equation? Solve d squared plus 4 into y is equal to 0. D squared plus 4 into y is equal to 0. Solution: d squared plus 4 into y is equal to 0. Put d is equal to m, that is m squared plus 4 m squared plus 4 is equal to 0, that is m squared is equal to minus 4, that is m is equal to plus or minus 4, is it? We know it very well. M squared is equal to minus 4, m is equal to plus or minus 2 values. This is equal to, look at the board, root minus 1 into root 4, is it? Root minus 1, root minus 1 is equal to I. This you have studied in your previous class, I think so, 9th standard or 10th standard. Root minus 1 is equal to I, that is why it is called imaginary root or complex number, imaginary root or complex number. That is why root minus 1 is can be indicated by I. This is equal to plus or minus 2I. When the roots are imaginary, say m is equal to alpha plus or minus I beta, but here alpha is 0, plus or minus I beta, I is, beta is 2. The solution is y is equal to e to the power of alpha x 0x into c1 cos beta x, beta value is 2, plus c2 sin beta x. This is equal to e to the power of 0, 0 into x is 0, e to the power of 0 is 1. Therefore, y is equal to 1 into c1 cos 2x plus c2 sin 2x. If you want, you can write this is equal to c1 cos 2x plus c2 sin 2x. So, when the roots are imaginary, this is the solution of the given differential equation. Now, we will go to the next. Solve d squared y by dx squared, d squared y by dx squared plus dy by dx plus y is equal to 0, plus y is equal to 0. Solution: given d squared y by dx squared plus dy by dx plus y is equal to 0. That can be written as d squared y dfy plus y, that is d squared plus d plus 1 equal to 0. That is, in the place of d, put m squared plus m plus 1 to 0. That implies m squared plus m plus 1 is equal to 0. So, we have taken it as a algebraic equation, that is why it is equal to 0. So, then how to find the value of m? It is impossible to do the factorization. So, we have to use the formula we have studied in your previous class, ax squared plus bx plus c is equal to 0, x is equal to minus b plus or minus root of b squared minus 4ac divided by 2a. This you have studied in your previous class. So, to find the value of x when it is not possible to find the ಫ್ಯಾಕ್ಟರೈಸೇಷನ್ ಅಪವರ್ತನದ ಮೂಲಕ ಕಂಡುಹಿಡಿಯಕ್ಕೆ ಸಾಧ್ಯ ಆಗಲ್ಲ ಅಂತ ಹೇಳಿದಾಗ ಆಗ ನಾವು ಈ ಫಾರ್ಮುಲಾ ಉಪಯೋಗಿಸಿಕೊಂಡು ಎಕ್ಸ್ ವ್ಯಾಲ್ಯೂಯನ್ನು ಕಂಡುಹಿಡಿತಾ ಇದ್ವಿ. ಇಲ್ಲಿ ಎಕ್ಸ್ ಬದಲಾಗಿ ಏನಿದೆ, ಎಮ್ ಇದೆ. ಟು ಫೈಂಡ್ ದಿ ವ್ಯಾಲ್ಯೂ ಆಫ್ ಎನ್ ವಿ ಹ್ಯಾವ್ ಟು ಯೂಸ್ ದಿಸ್ ಇಕ್ವೇಷನ್. So, according to this formula, the value of m is, that is, m is equal to minus coefficient of m, that is 1, plus or minus square root of b squared, b value is 1, b squared is 1, minus 4ac, a is coefficient of m squared, c is constant, that is 1, 4 into 1 into 1 by 2a, a is 1. This is the value of m, minus 1 plus or minus root of 1 minus 4 divided by 2. This is equal to minus 1 plus or minus root of minus 3 divided by 2. This can be written as minus 1 into minus root 3 minus 1 plus or minus I root 3 by 2. So, this is a complex number. This is a quadratic equation. This is not possible to find the value of m using factorization. So, to find the value of m, we have to use the formula. According to this formula, we have substituted the values a, b, c. At the last step, after the simplification, we have got it minus 1 plus or minus I root 3. This is minus 1 by 2 plus or minus I root 3 by 2. So, this is in the form of alpha plus or minus I beta. Alpha value is equal to minus of, beta value is equal to root 3 by 2. Therefore, the solution is, when the roots are complex numbers, when the roots are imaginary, then the solution is y is equal to e to the power of alpha x, alpha value is minus of e to the power of minus 1 by 2x plus or minus, e to the power of alpha x into c1 cos beta x cos root 3 by 2 plus c2 sin So, this is the solution of the given differential equation. Now, we will go to the next, the last very small bit, exact equation. How to solve the differential equation if the given equation is exact. If the given equation is exact. Exact differential equation. Exact differential equation. Exact equation. What is meant by exact equation? ಯಾವುದೇ ಒಂದು ಡಿಫರೆನ್ಷಿಯಲ್ ಇಕ್ವೇಷನ್ ಎಲಿಮಿನೇಷನ್, ಯಾವುದೇ ಟ್ರಾನ್ಸ್ಫಾರ್ಮೇಷನ್ ಇಲ್ಲದೆ, ಸಚ್ ಆಸ್ ಎಲಿಮಿನೇಷನ್ ಇಲ್ಲದೇ ಡೈರೆಕ್ಟಾಗಿ ಡಿಫ್ರೆನ್ಷಿಯೇಟ್ ಮಾಡಿದ್ರೆ ಬರುತ್ತಲ್ಲ ಅಂಥ ಇಕ್ವೇಷನನ್ನು ನಾವು ಎಕ್ಸಾಕ್ಟ್ ಡಿಫರೆನ್ಷಿಯಲ್ ಇಕ್ವೇಷನ್ ಅಂತ ಕರಿತೀವಿ. ನೌ ಅವರ್ ಪ್ರಾಬ್ಲಮ್ ಈಸ್ ಹೌ ಟು ಫೈಂಡ್ ಔಟ್ ದಟ್ ವೆದರ್ ಇಟ್ ಈಸ್ ಎ ಎಕ್ಸಾಕ್ಟ್ ಇಕ್ವೇಷನ್ ಆರ್ ನಾಟ್. Suppose if the given equation is the equation m dx plus n dy is equal to 0. The equation m dx plus n dy is equal to 0 is an exact equation, if delta m by delta y is equal to delta n by delta x. If this condition is holds good, then we are going to say that the given differential equation is exact equation. There are number of methods are there to find out the exact differentiation and to solve the exact differential equation. but according to your syllabus you are having only this method. When we are going to say that the given equation is whether exact or not. If it is an exact equation, this condition must be holds good. Delta m by delta y is equal to delta n by delta x. What is this, madam? You have written delta m by delta y. We know it very well. In the previous class you have seen that whenever you are going to use delta, that is an incrementary ratio. Delta y by delta x, it is an incrementary ratio y to x. But that is not the meaning here. Here partial differentiation of m with respect to y. Here partial differentiation of n with respect to x. ಯಾಕೆ ಅದನ್ನು ಪಾರ್ಷಿಯಲ್ ಡಿಫ್ರೆನ್ಷಿಯೇಷನ್ ಅಂತ ಯಾಕೆ ಕರಿತೀವಿ? why we are going to indicate this? First we have to understand, already you have seen this equation m dx plus n dy is equal to 0, variable separable method. In variable separable method, m is a function of x, n is a function of y. M is a function of x, n is a function of y in variable separable formula. ಆದರೆ ಇಲ್ಲಿ m is a function of both x and y, n is also a function of both x and y, where m and n are functions of both x and y. m ಅಲ್ಲೂ x ಇರುತ್ತೆ, y ಇರುತ್ತೆ, n ಅಲ್ಲಿ ಕೂಡ x and y ಪ್ರೆಸೆಂಟ್ ಆಗಿರುತ್ತೆ. when we are going to use this method, ಯಾವಾಗ ನಮಗೆ ವೇರಿಯಬಲ್ ಸಪರಬಲ್ ಮೆಥಡ್ ಮಾಡೋದಕ್ಕೆ ಸಾಧ್ಯ ಆಗಲ್ವೋ, when it is impossible to form the given equation in the variable separable form, then we are going to test this method. So this indicates delta m by delta y is equal to delta n by delta x. If this condition is holds good, this equation is called exact equation. Here we have to understand what is meant by partial differentiation. See, suppose the function z is equal to x squared plus 3xy plus y squared. I am going to differentiate z with respect to x. Then we have to take y as a constant. With respect to x ಮಾಡಬೇಕಾದ್ರೆ y ಅನ್ನು ಕಾನ್ಸ್ಟೆಂಟ್ ಆಗಿ ತಗೋತೀವಿ. With respect to y ಮಾಡಬೇಕಾದ್ರೆ x ಅನ್ನು ನಾವು ಕಾನ್ಸ್ಟೆಂಟ್ ಅಂತ ತಗೊಳ್ತೀವಿ. ಯಾವಾಗ ವಿತ್ ರೆಸ್ಪೆಕ್ಟ್ x ಮಾಡಬೇಕಾದ್ರೆ y ಅನ್ನು ಕಾನ್ಸ್ಟೆಂಟ್ ಅಂತ ತಗೋತೀವೋ, ವಿತ್ ರೆಸ್ಪೆಕ್ಟ್ y ಮಾಡಬೇಕಾದ್ರೆ x ಅನ್ನು ಕಾನ್ಸ್ಟೆಂಟ್ ಆಗಿ ತಗೋತೀವೋ, ದೆನ್ ವಿ ಆರ್ ಗೋಯಿಂಗ್ ಟು ಕಾಲ್ ಇಟ್ ಆಸ್ ಎ ಪಾರ್ಷಿಯಲ್ ಡಿಫ್ರೆನ್ಷಿಯೇಷನ್ ಅಂತ ಹೇಳಿ. ದಿಸ್ z is a function of x and y. We are going to differentiate z with respect to x. This is equal to 2x plus 3y plus 0. Suppose if you want to differentiate with respect to y, x is constant, derivative of x squared with respect to y 0 plus 3y plus 2y. So this is called the partial differentiation. Just to remember, this is when we are going to differentiate with respect to x, y we are going to take it as a constant. When we are going to differentiate with respect to y, we are going to take it as x as a constant. With respect to y ಮಾಡಬೇಕಾದ್ರೆ x ಅನ್ನು ಕಾನ್ಸ್ಟೆಂಟ್ ಆಗಿ ತಗೋತೀವಿ, ವಿತ್ ರೆಸ್ಪೆಕ್ಟ್ ಟು x ಮಾಡಬೇಕಾದ್ರೆ y ಅನ್ನು ಕಾನ್ಸ್ಟೆಂಟ್ ಆಗಿ ತಗೋತೀವಿ. ಆಗ ನಾವು ಇದನ್ನು ಪಾರ್ಷಿಯಲ್ ಡಿಫ್ರೆನ್ಷಿಯೇಷನ್ ಅಂತ ಕರಿತೀವಿ. ಇಲ್ಲಿ ಪಾರ್ಷಿಯಲ್ ಡಿಫ್ರೆನ್ಷಿಯೇಷನ್ ಆಫ್ m ವಿತ್ ರೆಸ್ಪೆಕ್ಟ್ ಟು y ಈಸ್ ಈಕ್ವಲ್ ಟು ಪಾರ್ಷಿಯಲ್ ಡಿಫ್ರೆನ್ಷಿಯೇಷನ್ ಆಫ್ n ವಿತ್ ರೆಸ್ಪೆಕ್ಟ್ ಟು x. ಪಾರ್ಷಿಯಲ್ ಡಿಫ್ರೆನ್ಷಿಯೇಷನ್ ಕೂಡ ಡೆಲ್ಟಾ ಅಂತಲೇ ಉಪಯೋಗಿಸ್ಕೊಳ್ತೀವಿ. ದಟ್ ಈಸ್ ದ ನ್ಯೂ ಥಿಂಗ್ ಫಾರ್ ಯು ಪೀಪಲ್ ಟು ರಿಮೆಂಬರ್. ಅಷ್ಟು ನಿಮಗೆ ನೆನಪಿತ್ತು ಅಂತಂತ ಹೇಳಿದ್ರೆ, ಜ್ಞಾಪಕ ಇಟ್ಕೊಂಡ್ರೆ ದೀಸ್ ಪ್ರಾಬ್ಲಮ್ಸ್ ಆರ್ ವೆರಿ ಈಸಿ. ಸೊ ಎಕ್ಸಾಕ್ಟ್ ಇಕ್ವೇಷನ್ ಅಂತ ಹೇಳಬೇಕು ಅಂತಂತಂದರೆ ಡೆಲ್ಟಾ ಎಮ್ ಬೈ ಡೆಲ್ಟಾ ವೈ ಈಸ್ ಈಕ್ವಲ್ ಟು ಡೆಲ್ಟಾ ಎನ್ ಬೈ ಡೆಲ್ಟಾ ಎಕ್ಸ್. ಜಸ್ಟ್ ಯು ಹ್ಯಾವ್ ಟು ರಿಮೆಂಬರ್ ಎಮ್ ವಿತ್ ರೆಸ್ಪೆಕ್ಟ್ ಎಮ್ ವಿತ್ ಡಿ ಎಕ್ಸ್ ಇದೆ, ಆದರೆ ವಿತ್ ರೆಸ್ಪೆಕ್ಟ್ ಟು ವೈ ಮಾಡ್ತೀವಿ. ಇಲ್ಲಿ ಎನ್ ವಿತ್ ಡಿ ವೈ ಇದೆ, ಆದರೆ ನಾನು ಇಲ್ಲಿ ಡಿಫ್ರೆನ್ಷಿಯೇಟ್ ಮಾಡೋದು ವಿತ್ ರೆಸ್ಪೆಕ್ಟ್ ಟು ಎಕ್ಸ್ ರಿವರ್ಸ್. ಎಮ್ಮನ್ನು ವಿತ್ ರೆಸ್ಪೆಕ್ಟ್ ಟು ವೈ ಮಾಡ್ತೀವಿ, ಎನ್ನನ್ನು ವಿತ್ ರೆಸ್ಪೆಕ್ಟ್ ಟು ಎಕ್ಸ್ ಮಾಡ್ತೀವಿ. ಆಗ ಅವೆರಡೂ ವ್ಯಾಲ್ಯೂಸು ಈಕ್ವಲ್ ಇದೆ ಅಂತಂದರೆ ಕೊಟ್ಟಿರೋ ಇಕ್ವೇಷನನ್ನು ನಾವೇನಂತ ಕರಿತೀವಿ? ಎಕ್ಸಾಕ್ಟ್ ಇಕ್ವೇಷನ್ ಅಂತ ಕರಿತೀವಿ. if the given equation is exact, its solution is integration of m with respect to x plus integration of n with respect to y this is the solution of constant. C is constant. See, integration of m with respect to x keeping y constant. Y is a constant, you have to take it as here, y is a constant. Integration of n with respect to y, but here we have to integrate only y terms and constant terms, not containing the x terms. X terms ಯಾವುದೇ ಇರಲಿ ಅದರಲ್ಲಿ ನಾವು ತಗೋಬಾರ್ದು. Excluding x terms, we have to integrate the remaining terms. For the first term is m with respect to x keeping y constant plus integration of n with respect to y not x terms, that is equal to constant, where integral constant, that constant is called integral constant. This is the solution of the exact differential equation. You have to remember here m dx plus n dy is equal to 0. In that m and n both are functions of x and y, both are functions of x and y. Then we have to verify whether it is an exact equation or not. It is an exact equation ಅಂತ ಹೇಳಬೇಕಾದ್ರೆ ಯಾವ ಕಂಡೀಷನ್ ಇರಬೇಕಲ್ಲಿ, delta m by delta y is equal to delta n by delta x. Partial differentiation of m with respect to y keeping x constant, partial differentiation of n with respect to x keeping y constant. If it is what's good, its solution is integration of m with respect to x keeping y constant plus integration of n with respect to y but not containing x terms. We have to take only the y terms and constants, but not the terms containing x, that is equal to constant, where that constant is called integral constant. If you do some problems, that completes the syllabus. First one, solve x plus y minus y dx plus x plus y plus 2 dy is equal to 0. Solution: given x plus y minus y dx plus x plus y plus 2 to 0, that is m is equal to x plus y, n is equal to x plus y plus 2. So, we have to see that first whether it is an exact equation or not. If it is an exact equation, that has to satisfy the delta m by delta y is equal to delta n by delta x. So, delta m by delta y, that means differentiate m with respect to y keeping x is constant, constant is 0 plus 1. So, this is equal to 1. Similarly, you differentiate n with respect to x, 1 plus 0 plus 0. So, when you with respect to x, when you are going to differentiate with respect to x, y is a constant. So, derivative of y with respect to x, that is 0. This constant is also 0. Delta n by delta x is equal to 1. Delta m by delta y, that is also equal to 1. Both are equal. Therefore, delta m by is equal to, so it is a exact equation, exact differential equation. Its solution is integration of m into dx, y constant, plus integration of when with respect to y, not x terms, is equal to c constant, that is integration of x plus y minus 5 with respect to x plus integration of n with respect to y. See, only not x terms, so we have to take only y plus 2 equal to 2, that is integration of x with respect to x, x squared by 2, integration of y with respect to x, we have to take it as a y as a constant. Therefore, plus yx minus 5x plus y squared by 2 plus 2x is equal to c. This is the solution of the differential equation. Sorry, this is 2y. This is the solution of the given exact equation. The second one, solve x to the power of 4 minus 2xy squared plus y to the power of 4 plus y to the power of 4 dx minus 2x squared y minus 2x squared y minus 4xy cube minus 4xy cube plus sin y dy is equal to 0. dy is equal to 0. In this, m is equal to x to the power of 4 minus 2xy squared plus y to the power. N is equal to minus of 2x squared y minus 4xy cube plus sin y. So now you differentiate m with respect to y. Delta m by delta y is equal to, x is constant, 0 minus 4xy plus 4y cube, So n differentiate n with respect to x, keeping y is constant, delta n by delta x minus 4xy minus 4y cube plus 0. Derivative of sin y with respect to x, y is a constant, so it is 0. This is 4xy minus derivative of x is 1, so minus 4y cube is there. This is equal to 4y cube minus 4xy. By observation itself, delta m by delta y is equal to delta n by delta x. So, it is an exact equation. Therefore, delta m by delta y is equal to delta n by delta x. Therefore, given equation is an exact equation. Therefore, its solution is m dx, integration of m dx keeping y constant, plus integration of n with respect to y but not containing x terms. ಇಲ್ಲಿ ಯಾವುದೇ ಕಾರಣಕ್ಕೂ x terms ಅನ್ನು ತಗೊಳ್ಳದೆ ಉಳಿದಿದ್ದ terms ಅನ್ನು ಮಾತ್ರ ತಗೋಬೇಕು. ಫಸ್ಟ್ ಇದರಲ್ಲಿ ಎಲ್ಲ ಟರ್ಮ್ಸ್ ಅನ್ನು ತಗೊಳ್ತೀವಿ, ಬಟ್ y ಅನ್ನು ಕಾನ್ಸ್ಟೆಂಟ್ ಅಂತ ಟ್ರೀಟ್ ಮಾಡ್ತೀವಿ. ಪ್ಲಸ್ ಸೆಕೆಂಡ್ ಟರ್ಮ್ ಅಲ್ಲಿ y ಟರ್ಮ್ಸ್ ಇಂಡಿಪೆಂಡೆಂಟ್ಲಿ y ಟರ್ಮ್ಸ್ ನಾಟ್ ಕಂಟೈನಿಂಗ್ x ಟರ್ಮ್ಸ್ is equal to c. That is, integration of m is x to the power of 4 minus 2xy squared plus y to the power of 4 with respect to x plus integration of n with respect to y, but we should not take x terms. See, first term containing x, the second term is also containing x. So, it is minus is there, minus into minus minus sin y with respect to y is equal to c. We should be very careful in taking second term. First term, whole thing m term we will take, but we are going to treat y as a constant, plus integration of the second term, but in the second terms we will take only the y terms, independently y terms. There is no x term. That is x to the power of 5 by 5. Integration of x to the power of 5, x to the power of 4 is x to the power of 5 by 5, minus is there minus 2y squared is constant, keeping y constant. So, 2 is constant, y squared is constant, integration of x with respect to x squared by 2 plus y to the power of 4, it is a constant, 1 with respect to x, integration of 1 with respect to x, that is x, minus integration of sin y minus cos y, integration of sin y is minus cos y. So, minus into minus plus is equal to constant. This is the solution of the exact equation. You have to remember this. First, delta m by delta y, you should be very careful. M actually with dx, but we are going to differentiate with respect to y, delta m by delta y. Y actually n is with dy, but we are going to differentiate with respect to x. So, reverse, delta m by delta y is equal to delta n by delta x. Once if we come to know that it is an exact equation, directly we will write solution is integration of m with respect to x keeping y constant, plus integration of n with respect to y but not containing n terms, x terms, is equal to c. Now, we will see the third one. Solve y squared minus x squared, y squared minus x squared y squared minus x squared dx plus 2xy dy is equal to 0. Just you see that this is an homogeneous equation and exact equation. See, y squared dy by dx is equal to y squared minus x squared divided by 2xy. Even in the first problem also, just I have shown no first one, second one, this is the third one. In the first problem also you can see that is the second method of the variable separable form. Dy by dx is equal to ax plus by plus c divided by a dash x plus b dash y plus c dash, where a by a dash is equal to b by b dash. You can use that method or this method, which is easy for you to remember. You remember that. So, this is a homogeneous equation and this is also exact equation. Now, we will see whether it is an exact equation or not. Solution: given m is equal to y squared minus x squared, n is equal to 2xy. Differentiate with respect to y, keeping x constant. This one differentiate with respect to x. Derivative of x with respect to x is 1, so 2y will get. Therefore, delta m by delta y is equal to delta n by delta x. It satisfies the condition. Therefore, it is exact equation. Once if it is exact equation, we can write the solution directly. Its solution is integral of m with respect to x keeping y constant plus integral of n with respect to y but not x terms, that is equal to some constant, that is integral constant. So, that is integral of y squared minus x squared dx plus integral of n with respect to x, n with respect to x but not containing x terms. So, it is only one term is there, that is containing x, therefore, it is 0 is equal to c. That is y squared is constant, integration of 1 with respect to x minus integration of x squared with respect to x So, this is the solution of the given differential equation. I think so it is very easy compared to the previous problems, but you have to concentrate how to form the differential equations. First one problem and variable separable method, and the first type of reduce the variable separable method, homogeneous equation, linear equation, Bernoulli's equation, second order homogeneous differential equation. Better you concentrate these 5 forms, that is enough for the examination. Okay friends, that ends the syllabus. I think so we have completed 100% perfectly and fully. We have not left out even single point. So, study well, score good marks, best of luck. Thank you.